Okay, the recording is started, so I think you can just try to present as you're going to present it right on the conference. So if you ask some questions during your presentations, I will try to answer them. So just let's go forward.
Okay, so it's the first time I'm presenting that, so it's not yet fully prepared. That's
Yeah, sure.
an idea, and I'm not sure about the timing. I believe it might be too long at the current form, so in later it might be a bit shorter.
Okay. That's fine. That's why we're doing the dry run. So
okay, so welcome in Efficient Kotlin, a presentation when you are learn how to speed up your Kotlin project. My name is Marcin Moskala. I have two books, Effective Kotlin and Android Development with Kotlin. And in this presentation, we'll concentrate on the content from the first one, Effective Kotlin. Book is divided into three parts: good code, code design, and efficiency, which are later divided into separate chapters. And in this presentation, we are learning how to make your code faster. So we will concentrate on this third part, code efficiency. Let's start with making our code cheap. So there are two important topics when we think about making code cheap and optimizing our memory. One is memory use, and another, that is the mother of all the problems, is object creation. And to understand what is the problem with object creation, we need to first understand some cost of objects. So when we take absolutely any object, first of all, we need to understand that it has some very, very small but yet existing costs. Even an empty object has each of them. So every object needs to allocate some space for its header. So it's taking 8 to 16 bytes per header. It needs to, whenever we reference object, we need to store this reference somewhere. So it's 4 or 8 bytes for memory reference, depending on if you use 32-byte system or 64. And finally, there is some allocation time. So object needs to be created, stored, registered, cleaned up. Those are very small costs, but how small exactly? And thinking about allocation time, we can make a benchmark to see how to some degree it takes. And here you can compare the creation and consumption of an object versus just consumption of an object taken from a property. And you can see the very visible and reproducible difference. It's very small, around 1 nanosecond, but yet it exists and it scales with the number of objects. So when you create thousands of objects, you already have thousands times this, a little bit more than 1 nanosecond. And this difference especially reveals itself when we think about primitives. So that an int, it should be 4 bytes. Int primitive takes only 4 bytes, when integer takes 16 bytes. It's a very small difference, but when you have millions of integers or millions of ints, it might be a significant difference, four times the difference in the memory, and we will see later how it can be controlled. There are other costs of objects in general. So object has its own state. State needs to be created. Object can be heavy, and clearly the heavier object, the more we need to take care of that. And so especially for heavy objects, there are tricks to avoid their creation or to properly manage them. Also, methods are kind of abandoned themselves. So when we, instead of doing something directly, when we do it through the function, there is a small cost of getting into this function and getting back from this function. We'll talk about it in the a little bit later. Those things are already to some degree optimized in JVM, and JVM does some optimization that supports that. For instance, when you use two exactly the same strings, it is guaranteed on the JVM that those will be the same object. So you can see that it's not only double equality is true, but also triple equality, which is a referential equality, that is checking if this is exactly the same object, is true as well. We also have some optimizations for integers. So first of all, we need to understand the problem. When you use nullable int, it cannot be a primitive under the hood because primitive cannot be null, and so integer is used under the hood. So if you use as a big number and you compare it, you might notice that even though those are equal to each other, the referential equality is not true, because under the hood different objects are created. As an optimization, JVM introduced a cache that works for smaller numbers. This is a implementation detail of JVM, and you can observe it if you do the same thing but for a small number, concretely from -128 to 127. Such numbers will be the same because it will be taken from the cache, so the same object. Of course, the good practice for the safety is to not use triple equality, neither from strings or for primitives in Kotlin. And if you use it for other kinds of objects, be very concerned, because in general it might be tricky, especially when you write multi-platform code. Do you have some questions or something to add?
No, not really. So everything's clear. So let's go forward.
So one trick that is commonly used in Kotlin to avoid unnecessary object creation is to use object declaration. So think of the following simple linked list implementation that has a head and tail. And one problem is that the empty object might be single one for all lists. And yet it needs to be, in the current implementation, it needs to be created everywhere and stored every time. So a popular optimization is to use object declaration instead of this class. But the problem is with generics. So now we need this single object to be subtype of every node. And the only way to make it true is that it needs to be of a generic type nothing, which is subtype of every type. And we need to introduce covariance, which is out modifier. And thanks to that, when a linked list with some subtype, when you have a linked list with a subtype, it can be treated as a linked list with a supertype. So linked list with int, it can be treated as linked list of number or linked list of any. And so linked list of nothing can be treated as all the linked lists. More about generics in other items, but the important notice is that out modifier is suitable only for immutable objects, and it can be used here because node is immutable. Another important way to prevent object creation is to use cache. As you already seen, it's used on JVM, it's used on many systems. It is very hard to implement correct cache, but it's good to know what it offers, and good to know because it might be useful when we create heavy objects and we might profit from caching. So let's start with a simple example. Empty list function needs to return an empty list, and we could create an empty list object every time, but instead, empty list function returns some property that stores this single empty list. It is again possible thanks to the same fact that list in Kotlin is covariant, and so this empty list is a list of nothing, and so can be used for used as any other kind of a list. Also, pretty useful caches are often caches are used to store heavy active records like connection with database or threads in a thread pool, and so it might be implemented as some map from a as some map holding those connections. And when we are asking for a connection, we are first checking if it is in the in this map, or if it is not, then we are creating that. There is though first the example, very simple example of Fibonacci sequence. So we know that Fibonacci can be implemented in a variety of ways, iterative, recursive, but it can be also implemented using cache that, and thanks to that, we'll never calculate any number more than once. So here is a very simple Fibonacci function with a cache, and when you calculate the value for the first time, any value for the first time, it is you can see it is slower than a classic iterative solution. But when you ask for value that is already calculated later, it's immediate because we are just taking it from the map and it's done. Of course, there is always one big problem with caches. Caches is trading efficiency for memory. So we need to store all this data somewhere, and we also need to take care of this data being cleaned when they are not needed. Because when caches are implemented as a static methods, they cannot be released, even though they might not be needed anymore. And it might be, if we have too many caches, it might be problematic for a compiler consuming too much memory and leading to out-of-memory exceptions. So those are memory leaks. So one important way to prevent that is to have some object references. And there are two key object references in Kotlin. So object reference is like a wrapper over value that do not strongly hold this value. So we have a weak reference, which is more popular, and it does not prevent an object to be cleaned up. So you can hold something and yet it might vanish, because if it is not used or kept by anything else, it can be just cleaned up. So it is a very weak relation that needs to be kept by something else, and we cannot, if we don't know if it is kept by something else, we cannot trust it. This is perfect when we want it to be cleaned as soon as possible, when we do not want to keep this object. So it's a good way to reference something that we want to use only if we know it exists. For instance, a dialog in a system, or for instance, the dialog. So if it's not displayed anymore, why would we want to do something with that? But there is less. There is a nicer reference. It's called soft reference. The problem with soft reference is that it might behave differently on different JVM machines, because it is not, the contract is not strongly defined. But the way it generally behaves is that an object you hold will not be cleaned up unless there is a lack of memory. So soft reference is generally quite a good choice for a cache. So we are holding something, but in the same time, if there is not enough memory, okay, this is cache, we can just let it go. So soft reference is a relatively good choice for caches when we want to have both caching for the efficiency and yet we do not want to have problems with memory. Another important technique is heavy object lifting. So when you in some cases it's pretty clear. So when you look at this max count, you might probably notice that it is doing way too much work than it should, because it iterates over each element, and yet inside each element it iterates over whole collection. So the calculation of this max should be lifted one level up. But this is rather clear. But what about this case? What is wrong in here? What is wrong in here?
Too complex regex.
Yeah. Okay, let's say that I cannot. I need this regex.
Okay, so the API address is obviously not correct.
But from the performance point of view.
From the performance point of view, okay, so it should be really slow, I think. Yeah, it's better. It's better to just to pass the four digits and then verify each of them is between 0 and 255.
Also, so this is the algorithmic part, but about this implementation particularly, one big problem is that this regex creation is pretty heavy. So creating a regex object from some string, it requires a lot of parsing, and later this object it is quite heavy.
Okay. So we need to cache the created regex, right?
Yeah. So the simplest way to cache it, and that is a similar example was also presented in Effective Java, is to keep it in some property. But supposing we are in the top level, and this is a static property, and we are getting to the problem we described before. So it will be kept forever. Okay, let's say this is not a problem for now. There is one more problem. So if calculation of this regex is heavy, suppose that this function is only one part of our like util functions or exte functions. Okay, so there are probably many more functions that lifted some objects above. So if so, the first time we need to use any of those functions, we'll first need to calculate all those heavy objects, what would be kind of an absurd. So it would be potentially heavy at the first use of any of those functions because they need to be statically initialized. So I believe a simple but better way to solve this problem is to use lazy. So object will be calculated on demand and later reused. So lazy often can be used as a very simple and yet powerful way to implement cache. Okay, lazy is also useful to make class less heavy, to make them lighter. So imagine that you have class A that produces and that contains and composes object of type B, C, and D. Okay. So suppose that class B, C, and D are heavy objects, what is not unlikely. In such a case, A is super heavy because when it's created, it needs to create B, C, and D. And one way to split to flatter this heaviness is to use lazy initialization, which in general which makes class A lighter because it postpones heavy object creation B, C, and D for their first use, and if they won't be used, for they do not need to be initialized at all. So this is a big profit of using lazy. But it needs to be remembered that it might also be a little bit tricky, because when this object is created during function call, so some function might be a little bit slower for the first time it is called, and it might be strangely reflected on some unit test or performance test applied in your application. So it might sometimes look like a strange behavior that, like the first time, something takes significantly more. So yeah, this is the initialization time that is postponed for later. And another thing is using primitives. So as we said, int in Kotlin in general is translated into primitive int, but when we use int nullable, we need to use integer. When we have a list of ints, this is a generic, so we cannot use primitive with generics at the moment. So it is translated into list with integers, and this is a very small difference, but it can make a change when we have when we have some algorithms that iterate over over many numbers. And here is some very simple implementation of max or null function finding maximal number or returning null, and it's not optimal because of there are a few reasons why it's not optimal, but one big one is that it uses int nullable, and it iterates and modifies this max many times. So every time we need to have integers instead of ints. The implementation that could improve it is a bit complicated, but it's actually the implementation that is present in the Kotlin standard library, where if there is no objects, we are just returning null, and later we treat we just take the first number as an initial element, and we iterate over others. The key difference is that here we cannot use a for loop. We need to implement ourselves using while. Okay, so another problem is, another suggestion, a bit more concrete suggestion, is to use inline modifier for functions with parameters of functional type. Why so? We first need to understand the cost of functions itself, the higher level functions itself. So imagine that you call some function for each that does something. So here is a for each definition. When you call this for each, when execution gets into this function, we need to jump into this for each, store an address where should we go back in the stack, and start the execution from inside. When we finish that, we need to go back. It's a very small change, but yet it's a tiny barrier that we need to pass. Every time we invoke action, we need to do the same in going inside this lambda expression, because this lambda expression is some other object holding a function. So we need to go into this function, and then we need to go back. Very small change, but it adds up. It is especially important when we are capturing some variable, because JVM does not support variable capturing, so Kotlin needs to store it in some external objects, and then whenever we access it, we need to pass some boundaries. And again, this cost adds up and can make a difference. So the solution is very simple, is to use inline modifier for function of functional types. When we do that, then during compilation, for each is replaced with the body of the function, and action call is replaced with the body of the action. And we have no barriers, and this can make a difference especially when we capture variables. So yeah, using line modifier for function with parameters of functional types. One additional advantage is that inline modifier, inline type argument in inline functions can be rayfied. What it means, in normal functions, generic types are gone, they are erased. When we use inline though, we are not really passing this barrier, so type can be placed into its use just like functions are placed into its use. Thanks to that, it is possible to, let's say, pass a type parameter and reference it, and using and let's say get its name. Another example, because during compilation this function will be replaced with the following body. This can be also, this is also used in some standard library functions. For instance, instance is filtering only instances of type worker, and it is not only filtering but also casting this, what is possible only thanks to the fact that worker is a rayfied type parameter, so we can check if something is of type worker. Oh, I think I have my yeah, there are clearly some costs of inline modifier. So first of all, inline modifiers cannot be recursive. What is clear, we cannot infinitively replaces calls with itself. Second is that we cannot use element with more restrictive visibility, what is presented in here. So here we have some function returning using reader, but it cannot be used because reader is private, so we cannot inject it because who knows where this read function will be used. And the third one is that our code grows when we use inline modifier. Or maybe I will skip that because there is too much of theory, too little about efficiency. Okay, a similar story is with inline classes. So why do we need inline classes? So what are inline classes? Inline classes are very simple classes with exactly one property, primary constructor property, and their characteristic is that when you have some code using those inline classes, then during compilation, these inline classes, just like inline functions, will be replaced with their bodies. So in this case, name will be replaced with string. If we use some methods from such inline bodies, those methods will be static methods, and they will be invoked statically with this actual value, like string in this case.
Okay, what's the benefit of that? Just not to have a class file?
Okay, I will get to that. So okay. Why do we need inline classes? The primary importance is that we use them to set types and yet do not pay for having those types. And those types are important, and there is okay, I need to add some parts on the slides, but those types are important, and there are two primary cases for which those additional types are very useful. And one of them is unit of measurement. So there is a story of NASA orbiter. It was manufactured in NASA, but they ordered a software in an external company. And it turned out that the company implemented software correctly, but they used different units of measure, so the hardware and software couldn't communicate properly, and NASA orbiter just crashed in the orbit of Mars, and so $50 million project was a total failure because they just used incorrect type. So types of units of measure are important, and they are very easy to mistaken them, and we are and we want to secure ourselves from this kind of problems. So imagine that you have some interface timer which we can set up to call after some time. But what is this type? It's very, very easy to confuse that. One typical way to prevent this problem is to add a unit of measure in the name. Well, it's to some degree helping, but it's very limited. So first of all, what if we return some units? We cannot name that. Also, it only secures us when we are writing code, but not necessarily when we are analyzing code or when we are, So here we have some user that decides about time and some timer that accepts time. And as we said, decide about time do not have how to specify what is the unit of measure. And so here user can decide about some time. We call it, it looks good, but it might be a total crash. Maybe user decided about 5 minutes or 5 hours, and timer expects milliseconds. So it is a bit tricky, and it is better to secure ourselves. So one popular solution is to add type, but the concern was type are heavy, so we don't want to introduce them. And the solution is inline classes. Inline classes are replaced with actual body, so they do not add any additional cost. So we can make inline class minutes that wrap over some value, or inline class millis. And then when we are forced to use that instead, when we decide about time, we know that those are minutes. When we accept time, we know those are milliseconds. And what is more, we just cannot mistake. You cannot make a mismatch because typing system would not let us do that. We would be forced to use a correct type. It is not in the slide, but inline classes can have also interfaces, and so we can have a freedom. We can here accept a time, and whatever kind of time is passed, it will be then processed into a correct unit of measure. So all those can be interface type. Type can has, I don't know, method 2 milliseconds, and so we will have a way to universalize it. So it will be then both safe and comfortable. Since wrapping over types is problematic, we also started using the idiom for that extension properties to create wrapped types. So we can make simple extension property to indicate that something is representing 10 minutes or 10 nanoseconds. So it makes sense only for well-known shorts, and there are also some projects to introduce that into the language, but for now it is an idiom that is well recognizable. So another type of scenario where inline classes help us a lot is, imagine is when we have the same type but with a different meaning. And imagine that you have a database, and database contains IDs. So on one table you might have user ID, school ID, company ID, etc., etc. So they are all of type string, but they come from a totally different domain. So it's pretty easy to accidentally use student ID as a where we are looking for company or ID or something like that. So here inline classes can also help us. So instead of, or here they are integers. So instead of having a bunch of integers, we can have a very concrete inline classes. And then when we use them, we are forced to use a correct type. So we won't use student ID when we look for by a teacher ID, say. Oh yeah, here is my example of interface time unit. So this is exactly what I said already. So universal way, time unit, and you can pass whatever you want. So easier for development and yet fully safe. And here many people ask me about type aliases, but I will skip this section because I think it's too long. So
Okay.
we might skip this section. And finally, let's talk about memory. And the key problem, the key guide for the key thing with memory is that we want to optimize our memory use. We need to take care about our object references, and whenever they are obsolete, whenever they are not needed, we need to clean them up. In Android, it is not uncommon, especially in older projects, to find the following pattern, which is right now known to be a terrible data leak. But yeah, so activities in Android are kind of like a window, and they hold a lot of data, so they are relatively heavy. And when we hold in companion object a reference to activity, we are holding a very big object in statically, so it cannot be cleaned up. It just cannot be cleaned up until we change it with something else. So when we do that, when we store this activity statically, it will be kept as long as our application is running, which is a huge data leak because on other screens it might be not needed at all. This is already known, but even people who know that are doing the same problem in a different way. So here, for instance, is some logger for errors. Is some function that is used to log errors. It can be set to set up one universal way to log errors for a class. But it is what you need to what you should notice is that this class stores this function reference, and this function reference captures a reference to the activity. It captures this, and so we not only store the whole activity. We need to make it alive, because otherwise this would be invalid, and we don't know when it will be used. So it cannot be correctly garbage collected, but also everything runs, so this function and everything else. So we made even worse data leak right now. So we need to remember that when you are capturing, you are holding objects that you use, you are capturing objects that you use, and holding a function statically is like an open invitation for data leaks always, because we don't know what people will keep on those, will capture on those functions. Here is another popular example. It's not static, but yet this object can hold way too much memory than it should. So here is an example of stack that has that holds an array. And whenever we push element, whenever we push element, we are placing it in this array. When there is not enough space, we are just making array bigger. When we are popping an element, we are just getting this element from an array and decreasing the size number. So what is wrong in here?
Multithreading is not accounted for.
So the point is here that, yeah, so when we are popping, we are only decreasing size, but elements are still kept in the array and they cannot be garbage collected.
Okay.
They cannot be garbage collected, so they are stored. So you can imagine that we populate this stack with 1,000 elements, and then we pop them one after another. And right now, our stock is empty, but it under the hood still holds thousands of elements. So it's an absurdish data leak. And a very simple solution to that is just to set nulls whenever we do not need something. So in this array, we might set null and when object is not supposed to be used anymore, and then it will be properly garbage collected. The same rule applies much further. Imagine that you implement a mutable lazy function. Mutable lazy function has some initializer, and when you get value, if it is not initialized, you use initializer to initialize it, you set initialize to true, and you return value. In set value, you are just setting value and initializing, and then set initialize to true. So this is quite okay implementation, but it has one data leak. And the question to the audience, and the actual problem is that this initializer is kept stored even when it might not be needed. So if our object, our class is already initialized, our object is already initialized, then we do not need this initializer anymore. And so it should be released because it's a function. We do not know what it stores. So it might store a reference to something heavy. So what we might do is that we might make it nullable, and we might set it to null. And notice that right now, setting initializer to null, I mean, the fact that initializer is existing or if it is null can also tell us if this class is already initialized or not. So this initialized property is redundant, and so it can be removed, and we can just check if initializer is initialized. If it is not, then we are using it to initialize value. We are setting it to null. If
okay,
sets
that's
it,
clever.
yeah. Okay. This is a part I haven't yet wrote, and it was about measurements, so that, okay, there are best practices we need to know and potential data leaks we need to be aware of. But the general idea is that we need to, when we proceed with the premature optimization is not good. What we should do is having measurements is to track the performance of our programs and applications. And when we see something takes too long or that something increased, we should monitor it. And when we see this change, then we should start analyzing and then doing these lower level optimizations. Most often, especially on backend, the problem is not in the code, but rather in some SQL queries or in some configurations, but it needs to be analyzed. Very useful thing is to have some use cases, problematic use cases, reproduce them in some automatic tests, measure performance of those tests, and when you optimize, we can check how this performance drops. Okay, one particularly important aspect of efficiency optimization in Kotlin is collection processing, because collections are very important in Kotlin and in other languages. In other languages, the Lisp language was taken, and the name was taken from list processing. When you think about absolutely any program, you can probably imagine tons of collections. When you think about shop, there is a basket, which is a collection, list of products, list of variants for each product, a list of payment methods, delivery methods, lists everywhere, and those lists needs to be processed, filtered, and this is what we will be talking about. In Java before version 8, there were no good way to process collections, so we needed to iterate and iterate and use basic functions. But Kotlin introduced collection processing, that is a set of extension functions on iterable or on sequence that let us do the same thing in much easier and more idiomatic way. Now it's very readable that when we take news, we are taking those that are visible, sorting them on descending by published date, and then we are mapping them to some adapters to display them. There are essentially two kinds of processing in Kotlin. One of them is iterable processing, and another one is sequence processing. From the side of from the use side, they are nearly identical because they support the same methods, and so they can be used the same way. In general, if I would just add a sequence in here, it would work exactly the same. I would only need to add two lists on the end. So they are very, very similar. Also, iterable and sequence are nearly identical under the hood. The difference is in the contract. So their behavior, the way how they process elements, is very, very different. So when you use an iterable processing function, and every step you are creating new list. So you are creating some list, and then you are populating it with an element. So under the hood, you are creating list at every step. This is nice when you have one processing step, because after it, you have a list that is ready to be used, ready to be stored or consumed. But it's not so nice when you have multiple processing steps, because all those list creation might not be needed and might be slowing down your program and using your memory. Totally different way is for sequences. So sequences are wrapping previous sequence in a class, so adding a new functionality using the decorator pattern, and thanks to that they can behave a bit differently. Okay, I need to reorder slides. So iterable works in an eager way at every step, creating new collections. And sequences work in the lazy way. So they are processing element by element. So first we are processing first element from the first one. So processing first element by map, processing first element by find, processing second element by map, processing second element by find. Notice that if you do not necessarily need to process all the elements, then lazy is faster, because it does not need to process all the elements. It is always processing our demand. So if you finish with find first, or if you have something like take inside, then sequence that is lazy might be better for the performance, because it does not need to process everything. Also, the order of because the order of those, because of the way how they are processed, the order is different. So here we process here one in lazy in sequence 1, 2, and 3, element by element, in iterable step by step. Notice that if you would implement those things yourself, so for loop with some ifs and for loops, etc., your way of doing that would be very likely lazy. So also the order is the same, would be the same as it is for lazy. So there are some projects of optimizing, of low-level optimizing collection processing, and it is not possible for classic collection processing because optimization would change the order, but it is possible for sequence processing because order is the natural order. Also, the problem with this is, of course, when we are wrapping, when we are adding map or filter, we are wrapping previous sequence, but at some point we need to get out of sequence. So we need this terminal operation. So this is this other operation that needs to be added on the end. Okay, the difference between those two is especially visible when we think about big things. And one very visible example is a processing over file. So a very simple way would be to take a file, read all the lines, and do some classic iterable processing. The big problem with that is that this file, Chicago Crimes CSV, it is a database of all the crimes that were taken in Chicago since 2004, and it takes 2.7 gigabytes of data. And on my computer, this very simple program throws out of memory exception, Java heap space. It is because here I allocated 2.7 gigabytes of data. Here I allocated another 2.7 gigabytes of data. Here I allocated another 2.7 gigabytes of data, etc., etc. So I just allocated too much data at the same time. Even if my computer would handle that, it would be still terribly slow. Of allocated all those collections and then releasing them, it would make it terribly, terribly slow. On the other hand, here is an implementation that is correct. Use lines uses sequence, and this uses sequence. And in this sequence, we are processing elements in exactly the same way. But thanks to the fact it's a sequence, we are processing elements line by line. So we never think about more than one line at the same time. So we are allocating a minimal amount of memory, and so this processing will be very, very fast. So yeah, so the same is the same is applicable not only to files, it is applicable to everything that is big and heavy. If this is a collection that has thousands, tens of thousands of elements, it is already big and it already needs to be populated, stored, and cleaned, and it's already a cost that can be avoided if we use sequence instead of a list. So sequences are better for big collections with more than one processing step. They are often, they can be infinite, and they have more natural processing. Notice that it does not mean that we should use sequence everywhere. There was such suggestion. This suggestion has two important parts. We need to have a big collection and more than one processing step. It does not mean any collection, and the warning that was introduced to convert everything, every collection processing into sequence, it is no what this suggestion suggests. For a small list of elements, less than 1,000 elements, according to my benchmarks, if there is no if there is no such thing as finishing on some one element like in find or first, then collection processing is generally faster because it can be in line, and sequences cannot because they produce new objects. Although one big one big advantage of sequences that needs to be remembered is that sequences can be debugged in opposition to list. A Kotlin plugin contains a sequence debugger. It sometimes has some troubles, but hopefully it works fine right now. And this is how it looks. You can use it to see how your sequence is processed at every step. Okay, and when we think about list processing, one more thing we can do to make it faster is limit the number of operations. For that, it's better to know more operations. Take a look at the following processing. What would you suggest to change in here to make it faster?
Filter beforehand, and then apply, then combine the two maps operations into a single one.
Yeah. So first of all, instead of filter and map and map not null, so instead of filter not null and then mapping to not null, we have a function called filter not null.
Okay.
And second of all, instead of mapping and filter not null, we have function map not null.
So, I didn't know that.
So we have plenty of functions that are alternative to few other functions, and thanks to that, we do not need to iterate over those collections more than once. So in here we iterate 3 times because we need to iterate one in this map, one in this filter, and again another one in this map. And in here we just iterate once, and because we do everything at once. So sometimes we have some suggestions from IntelliJ, but they are still very limited. So that's why I still keep this item. Hopefully one day they will be all well suggested by IntelliJ, and then I will just remove it. But for now, here is my small list of alternatives that should be used instead of some bunches of operations. So you also already know filter not null and map not null. Also, instead of mapping and then join to string, you can just join to string with transformation. Instead of 2 filters, what many people do, I see it too often. Instead of 2 filters, you can just make 1 filter and use AND. Instead of filtering and mapping to an instance, you can use filter is instance. Multiple sorted, you use, when you want to sort by multiple keys, you can use sorted with that accepts comparator, and you produce comparator with compare by, and then we compare by the first key, and if elements are the same in terms of the first key, we compare by another key. Instead of making a list and filtering out nulls, we have a list of not null, and we also have many indexed functions. So instead of adding index, of wrapping everything to index, and then doing things like filter and then doing some operations, you can just use map index, filter index, for each index, reduced index, and fold indexed. So if you need an index, you have indexed variants. I applied some changes and I already covered that. And when you do, this is a suggestion rather for game designers or for graphic library creators. When you have a huge number of integers or other primitives, for instance, if you have some matrix or a tensor, then instead of list, which is better for the usage, it might be better to use int array, because as we said, list is a generic type, so under the hood it uses an integer when we have a list of ints. Array of ints is also an array of integers, but arrays can actually hold primitives, and for that we have special types like int array, long array, char array, etc., etc. And int array is generally 4 times smaller and cheaper than array of int. Yeah, so when you, it's more. Okay, it looks like 5 times, but it's and because list adds additional overhead, but so this of course makes only sense when you very much care about performance, because it's like low level optimization. But when you have a huge number of integers and you do really care about performance, it might be a significant change. Like your list can be just 5 times smaller, and it is not only for memory, but it's also easier to process that, and so processing is cheaper. It's not so much big difference. It's about 20% difference, but still, it is a visible difference when you do something that needs high performance. On the first item of the book, I talk about limiting mutability and also preferring read-only lists, because you can yourself decide how it changes, where it changes, and you can apply and you can control the way it is modified. It is harder to control the way it is modified for multiple lists, but multiple lists are generally faster. And on one particular context, it is a big difference. When you have some function, some local scope, you know, nearly surely you know how it will be changed anyway, because it's all in this very small scope. And in the same time, it's very likely an algorithm that uses this list many times. So instead of using some normal instead of using read-only list, using multiple list might be of a big improvement. You can use functions like add all and add, and adding elements is generally faster. Maybe an example that iterates over elements would be better. Oh yeah, so it is visible on every basic collection processing function like map or filter, etc. They all produce array list, often with a set size at the beginning, and then they are using add. So if you would compare this solution versus solution that uses list of and var and adds new element every time, the current one is significantly faster. And finally, 2 words about computational complexity, another chapter that is not yet written, but I am considering that. So we will see if I will add it. I will probably need to cut off everything else, because I guess I took too much time already. So that's it, and thank you.
Yeah. Okay, that was awesome. Actually, I got some comments that I'm sharing with you in the Zoom chat.
Mm-hmm.
So I think we got like the full hour, and it's perfectly fine, because you have a 1 hour slot, and you can have all the questions afterwards in the discussion zone. So I see that you have some content that are still due to add, right? So you want to add something about benchmarking. This slide, the last slide, is obviously still have to add something. So I think that you need to think about like making something a little bit shorter, right? More concise, or maybe just dropping some things. For example, for weak reference and soft reference, I think it will be sufficient to just ask if everybody is familiar with the concept, because I believe our audience is familiar. But for all other tips and tricks, except maybe for the lazy function, that will be extremely useful. So yeah, I knew a lot. I discovered a lot today. Thank you to the representations.
Thank you.
Yeah, the only thing that bothers me is that we almost the presentation doesn't touch the multi-threading part.
Yeah,
but it's up to you.
I mean, yeah, it doesn't touch the multi-threading part because I decided to not talk, because as you know, classic multi-threading is probably obsolete in Kotlin,
Okay.
and coroutines are not yet, and are not yet even. There is no even clear guideline. I mean, it's like Kotlin team do not know how to use themselves. So every few weeks
Okay.
there is a different idea how they should be used. And I'm
Yeah.
actually crafting an article about one thing with structured concurrency. So this coroutine scope used to be passed, and right now it's hidden because it was problematic. So
Oh, really?
yeah, so
Okay.
I think it will be a good article, but I can show you something. If you use coroutines, do you use coroutines?
I used for several projects, but I'm stepped in a little bit other side of development. So now I'm playing a solution architect role. So I'm not like writing Kotlin code.
So I will show you something that is relatively new.
Okay.
Okay, so let's say that yeah. So when you use async or lunch, they are all extension functions on coroutine scope, yeah?
Yeah.
Yeah, but what about coroutine scope? Well, it is not. It is not. And
No,
it should
yeah.
be, because it is actually on the so if you cancel the parent, it will also be cancelled. And how so? You can see it in here. So it is suspended. When you suspend, you have a continuation.
Continuation, you're right.
They take context from continuation, and then they immediately resume that. So they are just using a trick to steal the context.
Yeah.
And this trick is not even needed anymore, because lately I was concerned, how is it so that when you use a flow,
yeah, that's another problem.
okay, let's say that when you use a flow, command flow, when you use a flow, you actually are also getting this, you are also having a relationship with parent. What is funny, you are having this relationship when you use collect. This is when you are getting the relationship. But collect is already an extension function on flow. So where is this connection formed?
Yeah.
I will tell you where it's formed. It's not so easy to show it, but I can have any function in suspending function, and have a relation with the parent whenever I want by using, where is that?
With context? No.
By using coroutine context. You see, coroutine context is an inline function, inline property that has a getter not implemented as intrinsic, not implemented error. Of course, under the hood it works, and it captures the coroutine context of the parent. So, so if I, let's say, with context new single blah 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 a, I call a.
And it will work, okay.
Oh yeah, so B, and here I need coroutine name. Come on, cooperate with me. Okay, so in here I can just do this computer not like Zoom, all like, you know, trying to fly, and every operations are too slow. Okay. So
okay. So it will take some time. Okay.
Yeah. Okay, but you can see it means AB.
Yeah.
So it actually has a parent scope, and this one is for me like a huge bomb. I mean, I know why they introduced that, because they cannot have more than one receiver on the function, and it's already a problem because they want to use receiver for many things, but it's hiding things, and yeah.
Okay.
So it's a trick. It's not good.
Okay, agree. Okay then.
I think
Let's wrap it up from here. So thank you very much. I will be sharing this video on the YouTube on the video with the private access, so access only with the link. So I will share the link to you and other folks from program committee. So maybe we will come up with some more feedback.
Sure, great, thank you. I will also be working, but probably closer to the date.
Yeah, of course. Thank you very much. Yeah, see you soon. Oh, one moment. I will stop the recording.